All right, let's go. Number 8, Planet 9. In 2016, 2 astronomers at the California Institute of Technology made an announcement that quietly rewrote the conversation about our solar system. Brown and Konstantin Batygin had been studying a cluster of small, icy objects in the far reaches of the outer solar system, beyond Neptune in a region called the Kuiper Belt. What they found wasn't a planet, it was a pattern. 6 of these distant objects were orbiting the sun in a way that defied statistical probability. Their elliptical paths were all tilted in the same direction, clustered together in a configuration so precise that the odds of it happening by chance were roughly 1 in 10,000. Something was pulling them. Something massive. Something unseen. Something orbiting so far from the sun that we hadn't yet pointed the right telescope at the right piece of sky to find it. Brown and Batygin called it Planet 9. Their calculations suggested it would be roughly 10 times the mass of Earth, larger than Neptune, sitting anywhere from 400 to over 1,000 times farther from the sun than Earth. At that distance, it would take between 10 and 20,000 years to complete a single orbit. It would receive so little sunlight that it would be nearly invisible against the darkness of deep space, a black body drifting through a black void, announcing itself only through the gravitational fingerprint it leaves on everything around it. What makes Planet 9 particularly unsettling is how confident the math has become. Since 2016, additional distant Kuiper Belt objects have been identified with orbital properties that align with the predictions. The anomalies are getting harder to dismiss, and yet despite dedicated searches using some of the most powerful telescopes ever built, including recent surveys with the Subaru telescope in Hawaii, the planet itself remains stubbornly invisible. It should be there. The math says it's there. We just haven't found it. Either something unprecedented sits at the edge of our solar system, enormous and silent, and we've simply been looking in the wrong direction, or the laws of gravity are behaving in ways we don't yet fully understand at these scales. Both possibilities are deeply uncomfortable. We've been mapping this solar system for centuries. The idea that something 10 times the mass of Earth has been out there the whole time, hiding in plain darkness, changes what we thought we knew about what home means. Number 7. Vulcan. Before Einstein changed everything, the best map of reality anyone had was Newton's. His laws of gravity had predicted the existence of Neptune before anyone had seen it, purely through the math of orbital mechanics. So when astronomers in the mid-1800s noticed that Mercury wasn't behaving the way Newton's equation said it should, the obvious conclusion was that another planet must be responsible. Its orbit was precessing, rotating slowly over centuries, and the precession was too large to be fully explained by the gravitational pull of the known planets. The French mathematician Urbain Le Verrier, the same man who had helped predict Neptune, ran the numbers and concluded something was there. A planet orbiting between Mercury and the Sun, so close to the Sun that its heat would make it nearly impossible to observe. He named it Vulcan. For decades, astronomers searched for it. There were false alarms, claimed sightings during solar eclipses, objects spotted crossing the face of the Sun that could not later be confirmed. Scientific journals published excited reports. Observatories pointed instruments toward the Sun's glare, straining to detect a small dark disk that should have been transiting across the solar face at predictable intervals. The planet had a name, it had a predicted orbit, it had serious scientific support, and it didn't exist. The resolution came in 1915 when Einstein published his general theory of relativity. The precession of Mercury's orbit wasn't caused by a hidden planet. It was caused by the curvature of space-time itself, a feature of the universe that Newton's framework had no mechanism to account for. Mercury sits deep enough in the Sun's gravitational well that the geometry of space around it behaves differently than it does for outer planets. The anomaly that pointed toward a ghost planet was actually pointing toward the incompleteness of an entire worldview. Vulcan's story is worth sitting with for a moment. A planet that didn't exist was still, in a meaningful sense, real, because it pointed us toward something true. The error and the discovery were part of the same process, and the uncomfortable implication is that today's undetected hypothetical planets might be doing the same thing. Some of them will be real, some will be Vulcans. The difficult part is that from inside the search, both look identical. Number 6. Nemesis. In 1984, two separate teams of paleontologists published papers in the same issue of the journal Nature, and both had arrived at the same troubling conclusion. Mass extinctions on Earth weren't random. They appeared to follow a cycle, recurring roughly every 26 million years with a regularity that pointed away from pure chance and toward an external cause. Something was periodically bombarding the inner solar system with comets and asteroids, sending them raining down on Earth with clockwork precision across hundreds of millions of years. Physicists Richard Muller and Mark Davis proposed the explanation. The Sun has a companion, a dim red or brown dwarf star orbiting at enormous distance so far out in the stellar halo that it completes one orbit every 26 million years. They named it Nemesis. As it swings through its closest approach to the Sun, its gravity disturbs the Oort cloud, the vast spherical shell of dormant comets surrounding the outer solar system, sending showers of icy projectiles cascading inward. Some miss, some hit, and every 26 million years, Earth absorbs enough of the impacts to push the biosphere past a breaking point. The theory is elegant and terrifying in equal measure. The end of the dinosaurs, the Permian extinction that wiped out 96% of all species, the half-dozen other great dying events scattered through the fossil record, all of them potentially caused by the gravitational wake of a dark companion star silently circling the outer reaches of our system on its long elliptical path. A cosmic metronome ticking in the dark, measuring time in mass extinctions. The evidence has never been confirmed. Wide-field infrared surveys of the sky conducted over the last 2 decades, most recently by the WISE satellite, have found no candidate star that fits the orbital requirements. Nemesis may not exist, but the extinction periodicity data that inspired the hypothesis hasn't been fully explained by any other model either. The cycle that pointed toward a dark companion still appears in the geological record. Something has been setting that rhythm. We just don't know what. Number 5. Theia. About 4.5 billion years ago, our solar system was a more crowded and violent place than the one we inhabit today. Planetesimals, the building blocks of worlds, were colliding, merging, and destroying each other constantly in the first few 100 million years after the Sun ignited. Among the bodies that formed during this period, a world roughly the size of Mars developed in an unusual position, sharing Earth's orbit around the Sun at a gravitational equilibrium point roughly 60 degrees ahead of our planet. Astronomers call such equilibrium points Lagrange points, and it's possible to maintain a stable orbit there essentially forever. This world, which planetary scientists have named Theia, stayed in that position long enough to grow to a considerable size, long enough to develop geology, long enough that it matters what happened next. What happened next was one of the most violent events in Earth's history. The gravitational interactions of the young solar system gradually destabilized Theia's orbit until the equilibrium broke and it fell inward toward Earth. The collision that followed wasn't a glancing brush. It was a slow, catastrophic merger between two planetary bodies, releasing energy so extreme that both worlds were partially vaporized. The resulting cloud of molten rock and debris coalesced in Earth's orbit and gradually assembled into something new. We call it the Moon. This isn't speculation. The giant impact hypothesis is the leading scientific explanation for the Moon's formation, supported by the chemical composition of lunar rocks, by the angular momentum of the Earth-Moon system, and by the near-identical isotopic signatures shared between Earth's crust and the lunar surface. Theia no longer exists as a separate world, but its remnants are still here, incorporated into the mantle beneath our feet and into the face that lights up the night sky. Every time you look at the full moon, you're looking at what remains of the planet that hit us, the ghost of a world that died so completely that its death became our most familiar celestial companion. Number 4. The planet of the Kuiper Cliff. Just past Neptune, beginning at about 30 astronomical units from the Sun, the Kuiper Belt is dense with small, icy worlds, scattered debris, and dwarf planets. Then, at around 50 astronomical units, something strange happens. The density drops off sharply. Objects become dramatically less common almost exactly at this boundary, far more abruptly than current models of solar system formation predict. If the belt simply faded out gradually, it would match theories about how material thins with distance from the Sun. But it doesn't fade. It stops. The edge is too clean, too sharp, too precisely defined to fit comfortably into models built around gradual processes. Something created that boundary. Something swept the material away at exactly that distance and left a cliff at the edge of the known solar system. Some planetary scientists have proposed that a Mars-sized or larger body occupies the region just beyond the cliff, its gravity having cleared the objects that once populated that zone over the history of the solar system. It would have had to have formed closer in, migrated outward, and then stalled at that distance, acting as a gravitational broom that pushed material either inward or out into the deep solar system over billions of years. The object responsible would still be there, a world of considerable size sitting just past the boundary it created, almost certainly too cold and too dark to have been detected by current instruments. The Kuiper Cliff is one of those anomalies in solar system data that doesn't generate many headlines, but quietly troubles the astronomers who work with it. The current models don't explain it cleanly. And unexplained sharp edges in nature almost always mean something is there that you haven't found yet. Number 3. A second sun. The solar system feels singular. One star, one gravitational center, one source of light that has been burning for 4.5 billion years. But our sun may be statistically unusual in that solitude. Surveys of nearby star-forming regions have found that the majority of sun-like stars form in binary or multiple star systems, gravitationally bound pairs, or groups that orbit each other across their entire lifetimes. Forming alone, as our sun apparently did, is possible but less common. Or at least, that's one interpretation. Another interpretation is that the sun formed with a companion, and that companion is no longer here. In 2020, astronomers Stephen Stoller and Sarah Sadavoy at Harvard published an analysis suggesting that the sun almost certainly formed with a binary companion, a star of similar mass that shared the same stellar nursery 4.5 billion years ago. In the dense, chaotic early environment of star formation, two stars orbiting each other at relatively close range could have eventually been separated as their stellar cluster dispersed. The companion would have drifted off into the galaxy, carrying no identifying marker, nothing in its composition that would allow us to trace it back to common origin with our sun. It would simply be one more ordinary star somewhere in the Milky Way, its connection to our solar system permanently and completely erased by time. The reason this matters goes beyond pure astronomy. The presence of a binary companion in the early solar system would have had profound consequences for how the planets formed, for how debris was distributed, for the trajectory of comets and asteroids during the period of heavy bombardment, when life's raw materials were first being delivered to Earth. We are, in a very real sense, the product of a stellar relationship that dissolved before the first single-celled organism ever existed. The other sun that co-created the conditions for our existence is out there somewhere in the galaxy, completely anonymous, carrying no memory of what it helped build. Number 2. A mirror matter planet. In the 1950s and 60s, as physicists began mapping the particle zoo in earnest, they discovered something the mathematics had hinted at for decades. Every particle of ordinary matter has a mirror counterpart, an antiparticle identical in mass but opposite in charge. Antimatter is real. It has been created in laboratories, detected in cosmic ray showers, observed at the centers of galaxies. The problem is that the universe we observe is made almost entirely of ordinary matter, and nobody fully understands why. The equations describing the Big Bang suggest that matter and antimatter should have been created in equal amounts and should have annihilated each other completely, leaving a universe of nothing but energy. The fact that we exist, that any matter survived, requires some asymmetry in the early universe that current physics can explain only partially. But there is a more exotic version of this question. Some theoretical frameworks, including certain formulations of string theory and supersymmetry, predict the existence of a parallel sector of physics, a mirror world where mirror matter interacts with itself through its own forces, but interacts with ordinary matter almost not at all. Not antimatter in the conventional sense, which annihilates on contact with regular matter, but a genuinely separate domain of physics that occupies the same space as our universe while remaining almost entirely invisible to it. Mirror matter would have gravity. It would clump. It would form stars, planets, and possibly structures of unimaginable complexity, all occupying the same cosmos as ours, but interacting with ordinary matter only through the gravitational force and almost nothing else. In 2019, researcher Leah Broussard at Oak Ridge National Laboratory conducted a series of neutron oscillation experiments searching for evidence that neutrons can briefly convert into mirror neutrons, quantum tunneling between ordinary and mirror matter. The results were intriguing, but inconclusive, and follow-up experiments remain ongoing. What makes the mirror matter hypothesis particularly haunting when applied to planetary science is its implication for what we might be missing. If mirror matter planets exist, they could be orbiting our sun right now, passing through the solar system, even occupying the same orbital zones as our own planets, completely undetectable by any instrument that measures light, radiation, or electromagnetic phenomena. We would feel their gravity and interpret it as a slight anomaly in the orbital mechanics of known objects. There could be worlds of vast complexity that share our sky, and will never share our sky at the same time. We will never see them. We have no instrument to build that would ever let us see them. They are the ultimate hidden worlds, not hidden by distance, but hidden by the deepest structure of physics itself. Number 1. A rogue black hole in our solar system. In 2021, Jakub Schultz at Durham University and James Unwin at the University of Illinois published a paper that combined two separate astronomical puzzles into one deeply uncomfortable proposal. The first puzzle was Planet 9. The hypothetical massive body whose gravitational influence appears in the orbital clustering of distant Kuiper Belt objects. The second was an independent set of observations from gravitational microlensing surveys, sky surveys that detect compact dark objects by the way. Their gravity bends light from background stars as they pass in front of them. These surveys had found a small number of objects in the outer galaxy that were too dark to be ordinary stars and too massive to be neutron stars. Objects that were consistent with primordial black holes, tiny black holes potentially formed in the first moments after the Big Bang, before any stars existed. Schultz and Unwin noted something striking. The mass range implied by the Planet 9 orbital anomalies overlapped almost perfectly with the mass range of the microlensing detections. Both sets of data pointed toward an object of roughly 5 Earth masses. Their proposal was direct. What if Planet 9 isn't a planet at all? What if the object responsible for gravitational sculpting in the outer solar system is a primordial black hole, smaller than a grapefruit, orbiting our sun at vast distance? The implications require a moment to fully absorb. A black hole, an object from which not even light escapes, an object born in the first microseconds of cosmic existence, 13 billion years old, orbiting our sun on an elliptical path in the outer solar system. It would be completely invisible. It emits almost no Hawking radiation at this mass. It wouldn't actively consume anything unless something came directly within its influence. To any instrument we currently possess, it would look exactly like nothing. An absolute blank in the sky distinguishable from empty space, only by the gravitational field it generates, and the faint arc it bends into background starlight when the geometry aligns correctly. This isn't mainstream science. It remains a speculative hypothesis with significant obstacles, but it hasn't been ruled out, and the search methods for a primordial black hole companion are actively being developed. The Vera Rubin Observatory, currently beginning operations in Chile, is designed to conduct the most comprehensive photometric survey of the southern sky ever attempted. Among its many scientific objectives is the detection of anomalous microlensing events within the solar system itself. If something dark and massive is orbiting the sun at 500 astronomical units, and it occasionally passes in front of a background star, Vera Rubin might catch the signal. Consider what it would mean to confirm this. Every civilization that has ever looked at the night sky has looked at a solar system with a black hole in it and never known. The object would have been there before Earth formed, before the sun ignited, before the molecular cloud that would eventually become our solar system collapsed into structure. It predates everything we call home. It has orbited silently through every moment of Earth's geological history, every mass extinction, every evolutionary leap, every civilization, and every generation of humans who have looked upward and wondered what's out there. And it would be the answer to that question that none of them ever expected. Not a planet, not a star, a hole in space itself threading through the outer darkness on its billion-year orbit, watching everything and showing nothing. The perfect final entry in any list of things that might be there and probably shouldn't be. The universe has a habit of hiding its most extreme objects in plain sight. Every one of these hypothetical worlds, from the gravitational ghost of Planet 9 to the mirror worlds that share our sky without ever touching it, represents the same uncomfortable truth. Our maps of reality are still incomplete. We've been making them for centuries, and the blank spaces haven't run out. If anything, the edges of the map are getting stranger the closer we look. And somewhere out there in those blank spaces, something is waiting to be found. Whether that prospect excites you or disturbs you probably depends on what you think gets found next. If you want to see more videos like this, click the video on screen now and make sure to subscribe.